All right, so section 9.1, we're going to talk about the 6 trig functions. So hopefully this is a bit of a review. The trig functions are a way to relate the angle of a triangle, the measure of an angle, to the measure of its sides. So we need to have some angle. This is the Greek letter theta. And then relative to that angle, you'll have a side that is adjacent or next to, a side that is opposite, and the side that is always the hypotenuse. Hypotenuse is always across from the right angle. So adjacent and opposite do depend on the angle you're talking about. So for example, if I was talking about this angle as theta instead, this side would be opposite. This side would be adjacent. And this side would still be the hypotenuse. Hypotenuse is always in the same place. So the 6 trig functions are defined as follows. You should also have these in your copy of the notes. And the idea is sine is, it's a button on your calculator. You can do the sine of an angle and it'll pop out a value. That value will always be equal to the length of the opposite side divided by the length of the hypotenuse. So sine of the angle equals opposite over hypotenuse. Each trig function has a different combination of sides. So adjacent hypotenuse, tangent, opposite adjacent, etc. Now, one way to remember sine, cosine, and tangent is SOHCAHTOA. And what this tells us is sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Now we're going to use this to either solve for a missing side, or in some cases we can use it to find a missing angle. Okay, first example. We're going to evaluate the trig functions of the angle theta. So right there. First, we want to find the length of the hypotenuse by using the Pythagorean theorem. So there's my right angle, there's my hypotenuse. This side is 5, this side is 12. So Pythagorean theorem, a squared plus b squared is c squared, or 5 squared plus 12 squared is equal to the hypotenuse squared. So square our numbers. 12 squares, 144. Take the square root of both sides. Turns out 169 is a perfect square. I believe it is 13. So our hypotenuse is 13 units. So now we want to evaluate all of the trig functions for theta. Right? We don't know what theta is, but we know if we plugged it in, put it in a calculator, sine would be equal to the length of the opposite side over the hypotenuse. So opposite, adjacent is next to, and then hypotenuse. So sine is opposite over hypotenuse, or 12/13. Cosine is adjacent hypotenuse. Tangent is opposite adjacent. cosecant, hypotenuse over opposite, secant, hypotenuse over adjacent, and cotangent, adjacent over opposite. Okay, so example 2 is a little more complicated. So it says, in a right triangle, theta is an acute angle, and the sine of theta is 4/7. We want to evaluate the other 5 trig functions. So step 1, we're going to draw the triangle. We're going to draw what's going on. So it says we have a right triangle. We have an acute angle. So theta is an acute angle. That's really just to say that theta is not the right angle. At this point, it doesn't really matter which one we choose, so let's just pick one. Let's call this theta. That's going to be our acute angle. And then the sine of theta is 4/7. Well, we also want to remember that sine of theta is going to be opposite over hypotenuse. So this also tells us that the opposite side has a length of 4. The hypotenuse has a length of 7. Now we need to find the length of the missing side, so let's do Pythagorean theorem. So a squared b squared equals c squared. So 4 squared plus, let's call this x for now, x squared equals my hypotenuse squared. 16 plus x squared equals 49. Take away 16 from both sides. We'll get x squared is 33. Take the square root of both sides. X is square root of 33. It's not really something we can simplify, so we'll just leave it as that. So just like before, we're going to evaluate our trig functions. So we're going to fill in the ratio. So cosecant, hypotenuse over opposite. So that's going to be 7/4. Cosine, adjacent over hypotenuse. So adjacent over hypotenuse. Secant, hypotenuse over adjacent. So it's going to be 7/√33. Now we do need to simplify this. So we're going to rationalize the denominator. So multiply top and bottom by √33. And we should get 7√33 over square root of 33 times 33 is 33. Good. Tangent, opposite over adjacent. So opposite over adjacent. So 4/√33. Again, we need to rationalize. We don't want to leave a root in the denominator. And again, square root of 33 times square root of 33 is 33. Cotangent, adjacent over opposite. So adjacent, opposite. Okay, so the next part, we're going to do our trig functions, and we're also going to use our special right triangles that we've talked about in a previous chapter. So this chart that you have on your notes, so you can find this on the notes on Canvas, it has our special right triangles, and then it has the trig ratios for each angle. So for the 30 degrees, for the 45 degrees, and for the 60-degree angle. Now, these are things you can find yourself using the definition of sine, cosine, tangent, cosecant, secant, and cotangent. And we're just using these triangles here. So these are our special right triangles, our 30, 60, 90, and our 45, 45, 90. The only difference is we've said that instead of having the short side as x, we let the short side be 1. Now the reason for this we'll talk about in the future, but it has to do with the unit circle. Okay, so number 3, we're going to use our special right triangles. So example 3, we're going to find the value of x for the right triangle. Now, we're going to do this using our trig functions. So we have an angle. We're going to use our given angle. So we're going to use our 30 degrees. Now, to decide which trig function to use, we just want to look at the sides that we have, so x and 8, name them, and then use the trig function that's appropriate. So this would be the adjacent side. This would be the hypotenuse. If we go back to SOHCAHTOA, well, adjacent hypotenuse, that's going to be cosine. So let's set up our ratio. We say the cosine of our angle is going to be equal to adjacent over hypotenuse. Now, from here, we can solve for x. So I could multiply both sides by 8. And we can say that x is equal to 8 times the cosine of 30. Now, this is a valid answer. This does have a value. You can put this in a calculator, but it's not a nice answer. So we're going to do this one other way to get a nicer number. So we're still going to use our cosine of 30 is equal to x over 8. We're also going to go back to our special right triangle. And we're going to take a look at our chart and find out, well, for our special right triangle, what is the cosine of 30? Now, we could draw the triangle, have x equal to 1, find cosine is adjacent over hypotenuse. But we also have this handy chart, so let's take a look. So cosine of 30, so 30 cosine root 3 over 2. So if the cosine of 30 is equal to x over 8, and the cosine of 30 is equal to root 3 over 2, well then x over 8 must also equal root 3 over 2. Cross multiply. So 2x is equal to 8 root 3. Divide both sides by 2, and x is equal to 4 root 3. So much nicer number. So let's go back up and we'll just apply what we know about special right triangles. It's a 30, 60, 90 triangle. Short side times 2 gives me hypotenuse. So 4 times 2 would be 8. And then the long side is always short side times root 3, or 4 root 3. So we can see, got the same answer for x. All right, example 4. So example 4 says, solve triangle ABC. When you're asked to solve a triangle, that has a specific meaning. Solve a triangle means find all missing sides and angles. So we need to know all 3 angles and all 3 sides. So first, we're going to find the measure of angle B. We know 2, we can find the third. So the measure of angle B plus 28 plus 90 must be 180. So the measure of angle B is going to be 62. All right. Add those together, subtract, get 62. Not too tough. Now, we only know one side, so we can't do the Pythagorean theorem. So we need to use our trig ratios to find A and C. Let's use the angle that's written. So we're going to use 28. And we need to use the side we're given. So we need to use that we know B is 15. Now let's find A first. So I'm going to find A. Now, based off our angle, B is going to be adjacent, A is opposite, and C is the hypotenuse. So if I want to find A, and I'm going to use B, I have adjacent, opposite. So going back to SOHCAHTOA, adjacent, opposite, we can use tangent. So I'm going to set up my ratio and say the tangent of my angle, 28. You always put a angle in here. So that theta that goes in next to a trig function, that's always an angle. So the tangent of 28 degrees is going to be equal to opposite side, which is A, over adjacent side, 15. Solve for A. Multiply both sides by 15. So A is equal to 15 times the tangent of 28. Now, if you're asked for an exact answer, that's it right there. If we want an approximation, we can put this in a calculator Scientific Calculator, Desmos, all have the trig functions. So this would be approximately 7.98. I strongly suggest whatever calculator you're using, try and put this in the calculator and see if you can get the same answers as me. There's a lot of weird things that can go wrong with trig functions that will give you a different decimal. These are things we can fix, but we got to figure this out now. Right. So we found A. Now we do not want to use A to find C. Because remember, A is an approximation. So let's just go ahead and start over. Let's use B and our angle to find C. So now we want adjacent hypotenuse. Adjacent hypotenuse, that's going to be cosine. So if we're going to find B, we're going to do the cosine of my angle will be equal to adjacent, which is 15, over hypotenuse, which we don't know, that's C. Okay, so we want to solve for C. We're going to start the same way. We're going to multiply both sides by the denominator. So multiply both sides by C. And we'll have C times cosine 28 equals 15. We want to get C by itself, where the cosine of 28 is just a value, it's a number. So we can divide by that number. So C is going to equal 15 over the cosine of 28. And again, if you need an exact answer, that's it. We can plug this into a calculator and get an approximation. C is approximately 16.99. Okay, so example 5, we have a word problem, we have a picture with our setup. So it says, you are hiking near a canyon. While standing at point A, you measure an angle of 90 degrees. Suddenly realized I probably shouldn't have filled that in. Now it's just harder to see. You measure an angle of 90 degrees between sides AB and so that looks like a typo. So it should be 90 degrees between AB and AC. So you then walk and measure an angle of 76 degrees between sides AB and BC. So that one's good. So as the picture is shown, the distance between points A and B is 2 miles. So that's the length we walked. We want to know how wide is the canyon between points A and C. So basically we want to find X. So we're going to use our angle 76 degrees. And again, we want to remember SOHCAHTOA. So based on this angle, this side is going to be adjacent. This is hypotenuse because it's across from the right angle I drew over. and this is going to be opposite. Adjacent, opposite, tangent. So I'm going to say the tangent of our angle is going to be equal to the length of the opposite side, which is x, over the length of the adjacent side, which is 2 miles. Solve for x, multiply both sides by 2. So 2 miles times the tangent of 76 is going to be x. Put this in a calculator, we'll get an approximation. Looks like it's 8.0 approximately, or maybe exactly. I'll have to double check. Okay, so number 6 says we have a parasailer is attached to a boat with a rope that is 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. Estimate the parasailer's height above the boat. So first, we're going to talk real quick about angle of elevation, angle of depression. So what is an angle of elevation? What is an angle of depression? For an angle of elevation and depression, you need somewhere to start, and you need something like an observer. Sometimes we'll use the ground as a reference. Sometimes we can use like a person or an object. So say if we're using a person, and the person is looking, say, straight ahead. That's our like reference. Now our starting point always needs to be parallel to the ground. Sometimes our starting point is the ground. If it's not, it always has to be parallel to the ground. Now say from looking straight ahead, we look up. So from your reference point, looking up, that's an angle of elevation. So say we have another case, and I'm not going to be too creative on this one. Let's say we're standing on top of a tall building. So it could be an airplane, could be a balloon, could be a person. And then we have the ground. So again, we're looking straight ahead, so that's going to be our starting place. And again, our starting place always has to be parallel to the ground. Now, from looking straight ahead, if we look down, that will be an angle of depression. So you always need a starting line. Looking up, angle of elevation, look down, angle of depression. And the starting line, wherever it is, must be parallel to the ground. Sometimes we do use the ground. Okay, so first step, we want to draw a diagram of our situation. So, parasailer is attached to the boat with a rope that is 72 feet long. So let's say this point is our boat. Our reference is going to be the water, so that's going to be our water. Then we have a rope tied to a parasailer. The angle of elevation from the boat to the parasailer, from our reference to the parasailer, 28 degrees. Right? Angle of elevation. So the rope is 72 feet long. And we want to know the parasailor's height above the boat. So if this is our reference point, this is flat. Our height, by definition, height is at a right angle. So we're going to use our trig function to set up an equation. Again, SOHCAHTOA. Here we have opposite and hypotenuse. Opposite hypotenuse, sine. So we're going to do the sine of our angle is equal to the length of the opposite side over our hypotenuse. Solve for h. So multiply both sides by 72. So 72 times the sine of 28 is our height. We can put this in a calculator and get an approximation. So our height is approximately 33.8 feet. And yes, we do need units of measure. If I forgot any above, we'll need to go back and fix that. So yeah, it's miles, etc.